So let us consider three hinged parabolic arch with supports at different levels. This parabolic arch, that means this profile of the curve is parabola. So here, whenever we have a problem of this category, then we can use the equation for parabola instead of whatever we have used for supports at same level, that is y is equal to 4hx by L square into L minus x. This is the equation of the parabolic curve we have used when supports are at same level. Supports at same level. This is equation to parabolic arch. So then if the supports are at different levels, here the origin is taken here at left support or right support. When they are at same level, origin will be at the one of the supports. When supports are at different level, we take the origin at the apex point, that is at the topmost hinge, that we take as the origin, and the x-axis we will take it in the horizontal direction, and y-axis we take it down like this. So in this case, with this arrangement of axis chosen, coordinate axis chosen, the equation to parabola, that is distance y, that distance y is from here, because that is the origin we have chosen. The distance, vertical distance, is this distance, not this vertical height as we have here. Here h is the maximum height from here, that is from that origin horizontal. Here the origin horizontal is there. Whatever y we calculate, it will be from top, from this x. That's one important thing you have to remember. And the equation to parabola, we can take it as some constant into x square. This is when supports are at different level. So this is the equation. Some constant is x square, where x is the horizontal distance from that origin. Origin is being at the apex. At any point x, either towards right or towards left, that distance is this y. So whatever price is given in the problem, so then that price minus this will give you usual this y, whatever we have in the other, when they are at same level. So that's all it has. The rest of the thing is similar. So first, whenever arch at different level is given, so we have to just, for whatever may be loading, we have to just use this equation instead of this equation for calculating that normal thrust radial shear. But for calculation of vertical reaction, horizontal reaction, same procedure. For finding the vertical reaction, that use sigma v equals 0, that is VA plus VB equals 0, and sigma h equals 0 will give you horizontal reaction equal at the two support. HA will be equal to HB, and you can take it as H, and so the third equation you can take it as moment about that top sheet is equal to 0. So sigma h equals 0 will give you the two horizontal reactions, here HB and here HA. So the two equations sigma h equals 0 will give you HA plus HB equals HA minus HB is equal to 0, or HA is equal to HB, you can say H. So the horizontal reaction will be equal. Then we can use sigma v equals 0, which gives you VA plus VB is equal to sum of the vertical loads. whatever vertical load which is acting here. Always we are talking about gravity loads, not inclined. Inclined means you have to resolve into two components, that's all. This is second equation. Then if you use sigma MA or MB equals 0, you can use it. You will get either VA or VB, you can calculate. Then you substitute here, you will get the two vertical reaction. This to find horizontal reaction, you can use sum of the moment about C equals 0. When you are using this equation, you have to take free body diagram either towards left or right. These two are two different parabola. So left side you will have one parabola up to here, it is here, then you can imagine it extends on the other side. So this is one parabola, you can treat it, and another right side parabola. You can take it like that, from that. In this case, if you are treating like this separate, in this fashion, if this is extended, if this span is twice L1, this span twice L2, you have to take it. That way, then we can use this first equation itself for carrying out the vertical ordinates. So, because this heads into that vertical ordinate, you have to use it. Either you can find out that horizontal reaction from this equation by calculating y, treating the two portions of the parabola in this fashion, or using this equation straight away. When you use this equation, you have to subtract from H1 these ordinates in order to get these. For this, from H2, you have to subtract these ordinates, except that there is no change in the analysis. The moment you get y at any point, normal thrust, radius here, everything is same, then calculation of that theta, that's also similar. Divided by dx, you have to find out, and that dx, you have to find out. Here, for this portion, either k may be equal, provided if you satisfy this length. I will derive that equation. If you satisfy the L1, L2, then you can use 1k. If you cannot satisfy, then you can use for this portion, you can use it as k1, for this portion as k2. Two different terms. With this information background, you can work any problem on this. So I will first derive. Suppose if you want to use one common equation y equals kx square, 1k if you want to use it, then you have to satisfy this relationship. So the equation to parabola for arches with different levels, can be taken in the form, y equals kx square with apex point C as origin as in figure, like that. So this case, so then we have for left portion, so you consider a parabolic arch having two supports at the ends at different level as here. At different level means one support is at height of H1, another support at a height of H2. The span being L. That's all the data will be given. And of course, load will be given. So I will just say here, so consider a parabolic arch of span L with left support, left and right supports at heights H1 and H2 respectively from apex point C, from apex point or hinge, apex hinge C, as in figure, like that. So the data given are only these three, along with loading. When that is given, then we can find out what should be the apex location from either left hinge or right hinge. If at all you want to use this equation y equals k square with one constant k, that's all. The same constant k, you can use it for calculation of this vertical depth. That you have to be very, very careful, not this from springing level. So I put fixed point C as in figure. Then for left portion, we have y. Y is nothing but H1, that is nothing but k into L1 square. X is L1. Correct? As x is equal to L1, y is equal to H1. Similarly, at x equals L2, y will be H2. So, and H2 equals KL2 for right portion. Right? Therefore, this H1 by L1 square equals H2 by L2 square, because each is equal to k. Same constant if you want to use, same equation of parabola. Or this you can write, or H1 by root H1 by L1 equals root H2 by L2. This you can write it as root H1 plus root H2 divided by root L1 plus L2. That's obvious. So this is nothing but root H1 plus root H2 divided by L. L1 plus L2 is nothing but L. That's what I told you. For the H1, H2, L is given. So you can find out that L1 is nothing but L root H1 by root H1 plus root H2. And L2 is given by L root H2 divided by root H1 plus root H2. So that's the relationship between this location of that apex hinge when they are at different levels, H1 and H2 from that apex point is given by that. Span this. Suppose if this is exactly the situation, then we can use only that equation y equals 4hx, kx squared as one of the constant. If suppose if the span or this L1, L2 they are different, if L1, L2 calculated is different, then if you have different this thing, then you have different equations for the two left and right segments. So that you can see, if L1 and L2 are different than given above, then we have to treat two parabola on either side of top hinge with equation y equals k1 x squared and y equals k2 x squared. Different constant. So first calculate k1 using this y1 square, that is h1 square, is equal to k1 into this, whatever the span. It is not exactly what L1 you got. If it is different, then you have to work out that k1, k2 separately, and you have to work out the ordinates using this equation at any point given using k1 and k2, two different values. Otherwise, you can use one constant k. That's all the thing. You have to tell. Now we have to remember in this particular arches, analysis of arches at different levels. The rest of the procedure is same. You are finding the reaction already I have given, and then once you find the reaction at any point on the arch, you can find the internal forces, that is bending moment, normal thrust, radial shear, with that same procedure, with applying the equations of equilibrium. Now we will take up one small example and close this chapter on arches, or at the same level or at different level. So, you see, find the support reactions, and the support reactions and the bending moment, normal thrust, and radial shear at a point 4 meters from left support of a 3-hinge parabolic arch of span 30 meters with left and right supports at 3 meters and 6 meters below top hinge. So I told you they will give the H1 and H2, the depth with span. They will give it. It's a parabolic arch. I treat here from this. It's parabolic arch throat. That's only one constant K. If they give L1, L2 also, then you can find two different Ks. That's all. Otherwise, it is same. Now, first step. With top hinge, the load, the arch carries a UDN of 20 kilonewton per meter on left of left of hinge, top hinge. Left of top hinge. So that means this is the arch. Here it carries a load of 20 kilonewton per meter, and you have a point. This L is equal to 30 meters span, and H1 is 3 meters and H2 is 6 meters. They are at different level. Span is 30 meters. It carries a UDL of 20 kilonewton per meter on left of top hinge towards on left portion of top hinge towards left portion towards instead of on you can say towards left portion of top hinge like this. So this is the sketch of this particular problem. So you have to find out the support reactions VA, VB and HA, HB as well as the bending moment normal thrust radius here at a point 4 meters from left. Yeah. At x equals 4 meters. Or I will say x1, capital X equals 4 meters. So that's all. So that is what this problem includes. So as usual, first step, you have to find the support reaction using that 4 equations of equilibrium, sigma h equals 0, sigma v 0, sigma m about one of the support 0 and moment about top hinge 0. So first step is find support reaction. So we can use sigma h equals 0, we'll have, so HA minus HB is equal to 0, or this HA is equal to HB is equal to H. Say, that's all. Then if you use sigma V equals 0, then you have VA plus VB is equal to the 20 into L1. We'll determine that L1. So to find L1, L2, we have y is equal to kx square. That's the equation we have. So for y equals h1, well, so y equals h1, which is 3 meters length, x is equal to L1. Therefore, 3 is equal to k into L1 square. Or we can use straight away that formula. We have L1 is equal to L root H1 divided by root H1 plus root H2. Because instead of working that calculation, we can remember the formula straight away and do it. So that L1 is nothing but L is 30 root of H1 3 divided by root 3 plus root 6. So this you can simplify. Similarly, L2 equals L root.
Sorry, L1 12.42.
12.42.
12.42.
Similarly, L2 equals L root H2 plus divided by root H1 plus root H2. This is 30 root 6 divided by root 3 plus root 6. Or this is equal to
17.58.
17.58. Naturally, the sum has to be 30 meters. L1 plus L2 has to be 30 meters. So you know now L1 is 12.42 and this is 17.58. Or if they give, this also in the problem. This has say 19 meters, this they can give as 14 meters. Then you use those figures. Don't bother, but still it is parabola with different k. Y equals kx square with different k. For this portion, it is k1x square. For that, k2x square. Separately, you have to calculate that for two portions separately, treating them as two parabola as I explained. Or when you consider two parabolas, then you can use your usual equation y equals k, that is 4h square h square l minus x, where that h is h1 for first parabola, for second h will be h2 and L is equal to whatever that, twice of that L1, L2, Q. That you have to take, and you can use that equation also, both. So this is that, and y equals kx square. So y for h1, if you take k into x is nothing but L1. Therefore, k is equal to h1 by L1 square. A constant also. You can. This is the equation to parabola. That's the equation to parabola. Why we need that means for calculation of normal plus radial shape, and also when you want at any height h. So this is nothing but either you can use this h1 equals k1 square or h2 equals kn2 square. Either one you can use it. This is h1 is nothing but 3 divided by 12.42 square. This you can simplify. You will get k1.
0.019.
Point
019.
19. That you can keep it. So next, we can find out VA plus VB is, therefore VA plus VB is equal to 20 into L1, 12.42. That is equal to 248.4. That is this as second equation. This has first equation. Then you can use sigma MA or MB. I will take sigma. Okay, MA equals 0. You will get VB
Minus VB into 30.
that is VB into
30 equals.
That is anticlockwise. Then
Equals
this H plus H into 3 meters.
6.
No. About A. We are taking moment about A. So this
minus
is H. This is that.
6
This
minus
H will not give any moment. Only HP will give moment about A. That you have to be very careful. Then
3.
VB into 30. This is anti-clockwise. This is clockwise. Minus H into 30. That this load. That is 20 into 12.12 into 6.06, half of that. So you will have equals 0. You have one equation, 30 VB minus 3H. This you can simplify. Or this is 10 VB.
So 1468.
1468.
68.9.
68.
0.9.
9. Or if I divide through by 3, I will get
489.6.
this. You can call it as equation 3. Then you can use sigma MC is equal to 0 by taking free body diagram either towards left or
Right.
towards right. I will consider towards
Right.
right because I will be reducing taking out one UDL. So this is the VB, this is H, that's all. This is L2, this is H2.
6 meters.
From this free body diagram, I will get VB into L2.
17.5.
17.58, that is in the anti-clockwise direction. Then this minus H
into
into
6.
L2, that is 6, is equal
Equals
to 0. Or 17.58 VB minus 6H equals 0. Or 2.93 VB minus H is equal to 0. Call this as equation 4. These are the equations we have. 1, 2, 3, 4. Solving this, you will get all the reactions. That is your first thing. Find the support reaction.
So VB 69.25.
So, if I
Solve 3 and 4.
subtract one from the other, automatically
VB.
this 10 minus 2.93 is equal to this.
Yes, sir.
So therefore, VB
VB equals 69.25.
Solving 3 and 4, we get VB equals
69.25.
69.25.
9.25.
Then
H.
from 2, H is equal to
202.9.
202.9. So many kilonewtons are.
Kilonewton.
These are all in kilonewtons. Then from 2, you will get VA.
248.
Because VA plus VB is that much, VA you will get
Minus
248.4 minus
9.2.
202.9,
179.15.
179.
Yes, sir. 248.
69.25.
Sir.
So it is 1,
179.15.
15. So you got all the reactions. VA, VB, H. That's all you have answered the first portion, support reaction. Then, at any point, you have to find the moment, normal thrust, radiation. That is same process. Absolutely there is nothing. Only thing you have to remember to treat that as two parabola if they are of not same as L1, L2 from that standard equation. You have to use different K1, K2. But for that, the procedure is same, whatever you have done. Next, to find bending moment, normal thrust, and radial shear. This is bending moment M, normal thrust N, radial shear or at D, which is at 4 meters from left support. Then this is 4. This distance is 12.42 minus
4.
4. So this you can work out.
8.42.
So that is
8.42.
7.58. 12.42 minus 4.
8.42.
8.42 meters. Because I am using this equation. So we have y equals kx square. Right? K you have already determined. So y equals k is 0.019 into x. X is what? 8.42. That you have to be very careful. We are taking this as the origin and hope. Otherwise, you have to take this as one parabola by assuming that to be extended by same amount. Whatever left side is there, that same amount you have to take and consider that usually. Otherwise, you have to work out that separately. This case. This x is nothing but 8.42 square. So this is
1.34.
Huh?
1.34.
34. So therefore, MD, bending moment about the point D, you take free body diagram towards this side. So this is our actual height required, y1. So this is y, whatever I have calculated, yd. This is yd. This is xd. xd is from here. That is xd. This is xd. So I hope it's clear with that notation. Therefore, md is equal to vp. Vp you have already determined. I will write that
69.25.
VB into that 4. VB into 4 clockwise. Then this MD is like this. Always have to take it in the opposite direction. So this is VB into 4 and this HA minus H into this Y1. That you have to be careful. H into Y1 minus this also like that, that's also like that. That 20 into 4 into 4 by 2. That's all. Moment about D. This into this into this, due to this. I worked out. So VB you have worked out. VB is 69.25. 25 into 4 minus H is 202.9. 202.9 into Y1. Y1 is nothing but
3 minus
3 minus
1.34.
this 1.34. This I will write it. 3 minus 1.34. So this here I will write that separately Y1 minus this is
160.
160. So you get
100.1.
how much?
100.1.
100.1
180.
kilonewton meter. So this is what bending moment at any point. So normal thrust radius here, you have to draw a tangent here, draw a normal. Along that, we have to consider the free body diagram towards left or right of that. Towards left I will take. Here you get VD and here you will get HD, the two reactions for this portion. To be in equilibrium. To be in equilibrium, this HD should be equal to H and VD is equal to VB minus this 20 into 4.
80.
So VD, that VD, HD, you resolve along tangent and normal, you will get normal thrust, radial shear. So you have to work out the theta. For working out theta, you take this equation, YD is equal to XD square, 5 dy by dx. You will get this for finding theta. So I will just give that equation. So normal thrust, first find VD is nothing but VB minus 20 into 4. VD is that 69.25, so that is 69.25 minus 80.
Minus
That is
10.75.
minus
10.75.
10.75.
75.
So that means it is minus means it is acting
Downward.
down. That is known. Then I have to take this VD is equal to this. Other way I have to take it, that's all. VB minus VD equals that. From that also you can work out. Then you can find out HD is equal to
HA.
H. That is nothing but HD.
202.9. 202.9.
202.9. Therefore, normal thrust is equal to, normal thrust means it is this, along the tangent. Along the tangent is normal thrust, radial shear is along the normal. So that is nothing but HD what? Cos theta, right? HD cos theta plus VD sin theta. And radial shear is equal to minus HD sin theta plus VD cos theta. So you get, to find theta, you can use that equation y equals kx square. That's the equation to the parabolic curve. or k1 x square, whatever it is. If it is of different length, then dy by dx is nothing but tan theta, that is nothing but
2k
2k
x.
x. So tan theta at x equals 4 meters, not 4 meters, you have to take x this.
8.42.
So that is 8.42 at x equals 8.42 meters is nothing but 2 into k, you have worked out 0.0, what is that?
0.019. 0.019.
0.19.
Sir, 0.019.
0.19 into x is 8.42. So you can find out theta from this. So substitute that value to get normal size radiation.
Theta
Whatever it is, so that is
17.7.
that is the problem. Even at different levels, only this small change is there that you have to take care. So this is about analysis of three hinged arch which supports at same level, different levels. Different levels, you have to work out that L1, L2, and if they are of same value, different disease, then you can have same value of K. If that value is also given, L1, L2, H1, has to go, all are given, then you can use two parabolas separately. You have to work out K1, K2 for the two portions separately, and accordingly this tan theta, you have to work out wherever they have as this normal thrust or radiation, the point. If the point is here, then you have to use y equals k2 x square, otherwise k1 x square like that. That's all. With this, the analysis of arches complete.